Welcome back. Today we shall be looking at units and dimensions. Previously, we discussed physical quantities, and now we shall be looking at units and dimensions. One thing I like much, one thing I like much about Empowerment First College videos is that you can pause the video at any time and continue at any time. You can replay the videos. For example, if you didn't get a concept where you can play back and you'll be able to understand. And now there are also scripts that are accompanied by the video. So you will be able to read the scripts and you'll be able to listen to the videos as well. So today we shall be looking at units and dimensions. Now, the best thing is for you to understand the definition because this is the beginning of this lesson, the beginning of your physics class. So the most important thing for you to do is to understand the concepts as they are used in physics and in the study of sciences as you progress. Now, units. If I say units, what do I mean unit? Now listen, a unit of measurement is a definite magnitude of a quantity defined. It is defined and adopted by convention or by law that is used as a standard measurement of the same kind of quantity. Any other quantity of that kind can be expressed as a multiple of the unit of measurement. Now, in physics, we when we are talking about units, we try to mention the SI unit. Now, the SI unit, the term SI unit means the international system of units. It is known by the international abbreviation SI in all languages. But sometimes, sometimes the system is in the form of modern metric system and based on the meter as as the unit of length, and either the kilogram as the unit mass or kilogram force. I can take that again. The international system of units is what is known as the SI. Now, the SI unit. So I say that it is known by the international abbreviation SI in all languages. So if you are reading a physics text and you come across SI units, it's the same thing we are talking about here. Just as I said before, this is the foundation, this is the starting. So this is where everything starts. So I am going to write the definition down so that you will be able to know or remember. So this is SI. Now SI, the international system of units. or unit. So I say it is known by the international abbreviation to be SI. To be SI in all languages. In all languages. So now, what are units? Somebody, I remember in some of the classes I have, some students ask me, so how do you define a unit? What is a unit itself? What do you mean unit? Now listen carefully. A unit of measurement is a definite magnitude of a quantity. Of a quantity. Okay, it is defined and adopted by convention or by law that is used uh, as a standard for measurement of the same kind of quantity. You know, it is defined and adopted by convention. By convention, sorry, or by law, that is used as a standard for measurement. Standard for measurement of the same kind of quantity. Of the same kind of quantity. So any other quantity of that kind can be expressed as a multiple of the unit of measurement. So this is what a unit means. A unit of measurement is what is defined and has been adopted as a proper uh, way of taking measurement, and it is known and accepted worldwide in all the languages. Now we have base quantities. As the next thing we are going to talk about. Base base quantities. Now, base quantities are those quantities which are distinct in nature, and in some cases, they have historically not been defined in terms of other quantities. Base quantities are those quantities on the basis of which other quantities can be expressed. The seven base quantities of the International System of Quantities and their corresponding SI units and dimensions. I am going to list them here so that you will know. Okay. And there are also other conventions. Other conventions may have a different number of base units. Like maybe if we are talking about the CGS and the MKS system of unit. But well, let me say how I can help help you understand some of the base quantities. We are going to learn them here. Base quantities. Base quantities are those quantities that are distinct that are dis I mean that they are distinct. Dis, distinct in nature, and in some cases they have historically not been defined. They are historically not being defined in terms of other quantities. In terms of other quantities. Okay, so the best way that we can learn about them is to have them in a table. So I'm going to make a table. so that I will list all of them for better understanding. The table will show international system of quantities, base quantities. So, first of all, names, then the symbols that represent them, then we have the SI unit, dimension. So if we name them, we name the common symbols and then their SI unit name and then the dimension. Okay, so let's say we have time. Time is also a, a, a base quantity, and we also have length, which is also a base quantity. We have thermodynamic or temperature. We have mass, amount of substance, electric current, luminous intensity, plane angle, solid angle. They are almost about seven, or more. All right. So let's say base quantities, length. Of course, when you're talking about length, you're talking about height, depth, distance, and width. All right. Now, the common symbol for length is L, L or T. Let's say T. Yeah. Then common symbol, and that's common symbol. But the SI unit for length, is meter. This is a meter. Meter. That's the SI unit. The SI unit name of the SI unit. Let me indicate so that you can understand clear. SI unit name for length is meter, and then the symbol, the SI unit symbol is M, and then the dimension symbol is L. So you can see So as you can see, now we are beginning to understand better. Now let's look at time. Time. The common symbol for, the common symbol for time is T. I am so sorry, I made a mistake in when I was talking about length. This the symbol for length, it can be in alphabetical form. It can be A, it can be B, A, B, it can be C, D, and it can be any letter. Because when you're talking about length, you're talking about the distance, X and Y, or A to B. Now, the common symbol for time is T. It can be small letter T or capital letter T. So the SI unit name for time is second. And then the common, the unit for time, the SI unit name is second. Then the SI unit is letter S. We use letter S to represent second is the SI unit name for time, and then the letter S is used to represent the SI unit, and then the symbol, the dimension symbol is T. That's the dimension symbol for time. And then we also have mass. Mass. Symbol for mass is M. And then the SI unit for mass, the SI unit name is kilogram. Kilogram. And the SI unit symbol is kg. And then the dimension symbol for mass is M. The letter M. Then we have thermodynamic temperature. Now, the symbol for temperature is T or phi. Then, temperature is measured in Kelvin. So, the SI unit name for temperature is Kelvin. And then the symbol is letter K. The dimension symbol is phi. Okay, so I would like to encourage you to try as much as possible to explore further, to study from the research center. You should study more about these base quantities. I am going to provide you with more materials so that you'll be able to read about many of them. We have electric current. Electric current. Electric current is represented by the letter I in Italy. Sometimes look like L. This is the electric current. It is measured in ampere. So the SI unit name is the ampere. And the dimension symbol is I. I is used as an electrical current symbol. Now, the amount of substance. Amount of substance. The amount of substance is represented by the common symbol N. N. Now, the SI unit name for the amount of substance is mole. Mole. And the dimension symbol for the amount of substance is N. Is N. So I would like to remind you that if you continue to study more about the SI unit, I mean the unit and the dimensions, you will come across some of the units that may be new to you. You may not be familiar with them. So I would like to encourage you to read more about units and dimensions. Although I will provide more resources and more lessons about them, so you will be able to know many of them. I am going to add of a few of the units here. I'm going to add few of them so you can be able to read them. on, let me say, luminous intensity. Luminous intensity represent the letter L with a subscript V, and the SI unit name for luminous intensity is Candela. And the dimension symbol for luminous intensity is J. J. And then we also have plane angle. Plane angle. Now, plane angle, the common symbols for plane angles are here listed. Okay, these are the common symbols for plane angle. We have the beta, and then we have the Y, and then we have phi, and then we have X. All these are the common symbols for plane angle. It is measured in radian. And the dimension symbol is known. We don't have a dimension symbol for angle, for plane angle. And then we have solid angle. Solid angle have these symbols, and this one. These are the symbol for a solid angle, and the SI unit is the steradian. And the symbol is SR. Now for radian, the SI symbol is RD. The radian can be written as SR. And then we have no dimension symbol for plane angle. For solid angle. Next, we are going to look at the general derived quantities.